Thanks so much for being here. I know it's the afternoon, so thank you for being here. I will be talking about safety as a systems problem. And my name is Shale. I'm doing my postdoctoral research at McGill and Miller University. And before I started my PhD, I was primarily trained as a roboticist and a biomedical engineer. So I come from fields that technically are very oriented towards safety critical systems. And it's really exciting to sort of see the conversation about systems within the context of business. But also earlier today, we had the conversation about evaluations, which will be sort of turning it back towards that and looking at what that means. So this is a poster from 1914. And this was a poster that was displayed in factories. And who do you think is the audience of this poster? Who do you think this poster was meant for? Any guesses? Men. Interesting. Any other guesses? The workers, yes. Yeah. So this was a poster that was meant for workers. And as you can see, it looks like such a great, it seems like such a positive poster. It says, put safety first and you'll reach happiness. But if you look at the other paths, it says if you're ignorant, you're indifferent, or if you're careless, then you won't reach happiness. And clearly you won't be safe as well. And the idea was that the connection between, education and happiness is being safety first, and then you have to be educated, to be safe, and then ultimately lead to happiness. And ideally, you look at this poster and you're like, this is such a positive message. What it does at its core is that it basically puts the responsibility of safety on workers. It says that if you're ignorant, if you're indifferent, and if you're careless, then you're basically going to injure yourself. So this was how we approached safety within the field at the time when machinery was being introduced within factories. But then as people start studying what safety is and how harms are caused, they realize there's a lot of system level issues. Now, more than 100 years forward, the question is, are we doing similar assertions when it comes to AI? And from some of the headlines that we're seeing, and from some of the small notes that is on ChatGPT saying that whatever we are creating has errors, there might be the chance that we're also still putting on blame on users for issues that they might not actually have a lot of control over. So here's what can we learn from safety engineering and the practice of safety that has been looking at, basically ensuring how we can manage harms for so many years. And this is one of my favorite sort of ways of looking at it, in the sense that, it has taken a long time for us to operationalize safety practices for different industries, as many people in this room have alluded to earlier on in the day. For example, the first commercial electrical system came in 1882, and the first sort of regulation that mandated the use of protective equipment for personal protective equipment was in 2000. That's quite a while. And so during my PhD, I was trying to really look at safety engineering frameworks, specifically trying to look at failure and hazard analysis frameworks, and seeing how they could be applied for AI systems. Looking at these frameworks, so you don't necessarily need to remember the name of these frameworks. Some of them you might recognize. I already saw some of the terms that were being referred to earlier on today. But the main point was that when we look at the progression of these frameworks within safety engineering, there's already this recognition that we need to look at safety from a system perspective, and that looking at only components of a system. So for example, for a bike, just looking at the tire or the brake and making sure that those are safe is not enough. We need to look at how the bike fits together. We need to know how the user ends up actually using that bike. And we need to make sure that the bike roads are actually there and are safe for the bike to actually be able to exist on and sort of have a safe bike ride. And so this shift was already recognized within safety engineering. And one of the main sort of works and the leaders in this space, Nancy Leveson, talks about safety as an emergent system property that arises from interaction of different components. And so a system defined within system theory is basically a set of components that has a specific goal and objective. And these components are working together to reach towards that. And that we should be looking at safety as the property of a system rather than a property of the components. But what is a system? What system boundary do we really look at when we're looking at AI products or the AI, the AI ecosystem. And there could be many ways we can define a system boundary. I think today in the conversations, different sort of conversations and different talks have alluded to different system boundaries that we could be looking at. One sort of the way, abstracted away system boundaries that we can look at the AI products and how the different data sets and different models and different UIs are actually put together to create an AI product. We could be looking at the system at the user and the community of users level, where we can see how a product is integrated within a community and how different users are interacting with that product. We also have a whole system of individuals, teams, and also automated parts that are actually basically creating a product and have a lot of influence on what is going to actually end up being in that product. And then we also have a lot of processes and around governance that actually sort of dictates what's going on and how we actually build the system. So there could be many systems within this. There's many system boundaries that we can look at when we're looking at how to evaluate basically safety. And so that is something to really try to really ask and about in terms of which system boundary do we really care about, and are we looking at in order to understand safety related issues? Are we looking at what's going wrong with our governance? Are we looking at what's going on with our institutional processes? Are we looking at what's going on with how we're integrating our data sets and models, or are we looking at what's happening at sort of the user and the community of user level? And the system dynamics that's really important to examine here is the first one is the interactional components, really looking at the interaction between the different components. How are different agents potentially interacting with each other? How's that all fitting together? But also ultimately, this idea of the different at the institutional level, how are we bringing maybe different agents into different parts of an institution? How are those actually interacting with different people that are acting as decision makers? That is going to really dictate what safety is going to look like. And ultimately, at more of the ideological level, what are we prioritizing as a society in our laws and our regulations that is going to ultimately tell us what what is safety, what values do we really care about, and how does that come into play? So in one of the cases that I had looked at to try to really map some of these system safety frameworks, and was looking at use of text-to-image models in creative practice. And the typical way of looking at text-to-image models and the safety really tries to look at, okay, are we creating an image that is harmful? And that is really, really important. But when we were trying to apply the safety engineering frameworks, we really try to look at what are the different layers that are involved in making decisions about the monitoring the safety of this text-to-image model. So we have the complexities are quite big here, but obviously this diagram is much more sort of simplified version. But we have decision makers at the AI governance and policy level, which are then talking about what are the policies and the red lines that the product team has to take into account. And then that ultimately trickles down to the production application layer, which brings together how the prompts and the safety classifier and the text-to-image model will actually ultimately interact in order to manage that text-to-image model service and then generate something for the user. And one thing, when we're drawing these system diagrams, one sort of potential issue that is relatively visible quickly is that sometimes there are these missing feedback loops between the different actors in our system, and these missing feedback loops, it could be one of the causes in which potential issues can arise. And so if for example, the product requirement team is not in conversation with the AI governance and policy team about ultimately what requirements they're going for and whether that actually aligns with the governance and policy requirements, then that is a relatively potential cause of harms that could happen and sort of ultimately down for the user. And so what does this really mean when it comes to designing and selecting evaluations? And this is a project that I've been working on sort of throughout my PhD. And the idea was that we recognize that there's a lot of different angles and approaches for evaluations and improving evaluations for AI systems. One of the main approaches has been looking at what we can learn from measurement theory perspective. Some of the speakers today earlier very much have contributed to this field to ensuring that we have construct validity and reliability for our benchmark and for our measures that we're developing. There's been also a lot of conversation on context and importance of context and interactions when it comes to developing evaluations. And so the idea here is that we are now focusing on a lot on sort of model level evaluation, but what does that look like when we're actually deploying the system, and that was very much discussed about earlier today. And also there's this line of work that talks about the fact that a measure itself, in some sense, or a benchmarks in some sense, have values embedded in them. They potentially, and that when we are developing these systems, we need to be able to have democratic processes that we go through in order to create these evaluations and these benchmarks, and that we need to really think about who is involved in creating these benchmarks and these evaluations. So what does the system safety perspective does here is that it's a complementary perspective to these three different angles that already exist. And the idea is that we want to try to connect the measures that we are developing to specific attributes that we are trying to that measure is trying to assess about a specific system component, and ultimately see whether, if we are implying that if this measure passes a specific criteria, then it means that we're in a hazarded state, and that hazard states is going to lead us to a potential harm to a user. So the idea is that right now, when we're designing these measures, we might not necessarily actually connect this attribute of the measure that we are designing to a potential hazard and ultimately a potential harm, and that these judgment calls are being made, but that we're not actually making these connections very explicitly. And can we try to do that? And the reason that this is important is that because when we're drawing these system diagrams about how we're developing AI systems, measurements are a form of feedback, and they are signaling something to the decision makers, whether they're automated decision makers or human decision makers, about potential things that are going wrong in your system. So they are signaling something, and they are often signaling a hazard or harm, but we're not being necessarily always explicit about what they're signaling and what we're paying attention to there. So in this work that we were doing, we went way back. So if, I think some individuals here have been in the field for quite some time, and who remembers AI ethics principles and sort of when they came about, in 2016, 2017, they were very much in the main approach to talking about sort of AI ethics at the time. And the AI ethics principles that were formalized at the time started really sort of shaping the type of measures that researchers were proposing. And so we tried to look at in this work how are the measures that were designed to assess adherence to AI ethics principles mapped to different components of an AI system, and what attributes do they capture, and then ultimately what types of hazards and harms do these measures signal. And so in our work, we reviewed papers from computing literature between 2011 to 2023. We looked at 11 AI ethics principles, including fairness, trust, transparency, dignity, sustainability, and so on. We ended up gathering 257 papers that were proposing measures to assess adherence to these principles. We converted these papers. Each of these papers generally had more than one measure that it was proposing or talking about. And so we converted this to a data set that we ended up calling response by AI measures data set. And we documented what these measures are trying to get to by looking at what measurement process they have, if there's a stated criterion for that measure, what principle they're measuring, what system component they're measuring, what type of assessment it is, and what what attribute, what hazard and harm each of these measures is trying to signal based on what that paper is how that paper is framed. And so from this work, we created this data set, which is available. Hold on, let me which is available online. So I'm just going to try to see how I could play this video. It's not quite working. But anyway, so there is a data set that is available and open, and it has 18 columns with that provides information about each of these measures. The idea, and from this we've seen some really interesting patterns. Obviously, one thing I want to caveat here is that this space is moving at really fast speed. So there's so many measures that continue to keep being developed. And the idea wasn't necessarily for this to be entirely comprehensive, but to sort of see what are the trends that we are observing. And one of the key elements here is that, so we looked at 11 AI ethics principles that are listed here. We looked at the principles that come from a systematic review done by Jobin and al. As some of you might be familiar with that work. And not so surprisingly, 90% of the measures that we had came from principles of fairness, transparency, trust, and privacy, and which we call high prevalence principles. And only just about 10% of the principles were covering all the other 10% of the measures were covering all the other principles, such as sustainability, dignity, solidarity, and so on. And there were some measures that were mapped to more than one principle. For example, we saw measures that were mapped to privacy and fairness. We also we mapped the measures to 5 system components of data, model, output, and user and output interaction, and also the full system. Most of the measures were targeting the model and output for the high prevalence principles. For some of the low prevalence principles, such as dignity, solidarity, and so forth, we saw more measures that were looking at user interaction, which makes sense. And primarily the sustainability measures were looking at the full system. So these were measures that were looking at how much energy is being consumed at different times of training and inference and so on and so forth. So they were more oriented towards the system. And lastly, when we were looking at, when we were mapping measures to harm, we mapped them to 5 different types of socio-technical harms from the taxonomy by Shelby and al. And these were harms of allocative harm, interpersonal harm, social system harm, representation and quality of service harm. Given the diversity that the category of interpersonal harm and social system harm covers, we saw a lot of measures that we thought broadly signal these types of harms. But and sort of there's some interesting sort of patterns for each one as well, which the paper that we have discusses quite a bit of. So one thing is that when we were looking at each of the harm types, we could see patterns in what attributes and hazards we're looking at for each harm type. So for example, representational harm had about 4 categories, broad categories, and I won't be able to cover all the categories for each harm type, but I'll just briefly cover a couple of categories for each harm type. For example, representational harm, a lot of the measures were not, so surprisingly, we're looking at representation of identities within data set and representation of identity within the sort of the latent spaces of models. There was also some measures that were looking at misalignment between what the model is outputting and the user identity. For allocative harm, most of the measure had to do with the disparate outcome distribution. So whether people from different protected groups are getting different outcome, which was relatively expected. There was a small category of harms on perceived decision fairness. For quality of service harm, which was relatively our smaller group of sort of measures, a lot of the measures looked at performance quality disparities, and some looked at user experience quality. For interpersonal harm, we had a wide range of categories. One of the categories was looking at design level privacy intervention. So measures such as k-anonymity would fall under that. And then also there were measures with influence on the user behavior. So how much AI systems are influencing the user behavior. And then for social system harm, there were some measures that had to do with on how well the user understands the system. And this was part of social system harm because information loss is part of that social system harm type. And also resource intensity, which was about how much CO2 emissions or how much energy these systems are using. And so that fell under social system harm as well. There's a lot of details about what are the different sort of attributes and hazards that are associated with each harm type. But the key thing was that we could see this clear pattern in what computing literature is sort of trying to assess in terms of attributes and hazards for each harm type, which is something it's good to be aware of, because there could be some blind spot in general about sort of what hazards and attributes we're trying to assess more, and ones that we are not necessarily covering as much. So one example that I think it's interesting is that, when we were looking at interpersonal harm, there were measures, with each of these components across the system. And so, for example, for data and input, we would have a measure such as inverse trace of Fisher information metrics, which tries to look at how easy it is for somebody to identify sensitive information from basically having access to the data. And then the idea was that this measure, we mapped it to a hazard of individuals could be identified. And then this was mapped to the harm of privacy violation, which is part of interpersonal harm. We had measures and hazards across the different components. So for model, we had mutual information. For output, for example, we had the honest score, which looks at how harmful the completion is. And if, for example, this measure is high, then the user could be exposed to harmful information. That would be the hazard. We had other measures for interaction with user. For example, this could be like, is the user accepting a lot of the suggestions from a system? And that can indicate over-reliance or under-reliance on a system, and that could be hazardous depending on how well the system is performing. And then there was also a set of perception-based measures that we're observing as well. And so the key question here is that, when we're designing a system or product, there are all of these measures at different points that different actors are introducing, but which one of these do we need to really care about? Which one of these measures are important? Which one of these, how many of these measures are essential when we're saying that we're measuring something at the system level? And so having a mapping of what different parts of your system you're measuring and what each of those indicate can give us a sense of what you're capturing, what is not being captured. And so what does this ultimately mean when we're applying a system safety approach to looking at evaluation? One thing is that, one thing we saw was that measurements that we looked at are very much fragmented across system components. This is not necessarily a bad thing. We did see a lot of focus on model and output measures, but we think that is not giving us a full picture of what is happening, and that we need to be looking at measures at other parts of the system. We really clearly saw that there was, when we were trying to link the measures to harms, it was definitely, there wasn't a lot of good links and clear links between that measure and what that actual harm is and that experience harmed is. And so the measures are taken quite far from where the harm is experienced. And this is something that has already been recognized in quite well from sort of different aspects and different perspectives that's been covered in the literature. There was a general lack of clear criteria for identifying what is a hazard when it comes to these measures. And the one thing that we also noticed is that time was something that was relatively overlooked. So how should we look at these measures over time? And whether time should be something that should be factored into one of these measures was something that relatively was not discussed as much. And lastly was that, what is the role of perception-based measures when it comes to looking at assessing of hazard and harm? So we did capture some perception-based measures that are as proposed within the computing literature, but it was very difficult to see how would somebody interpret a perception-based measure. So for example, one of the things was, one of the perception-based measures that we had was a dehumanization scale, which assesses whether the user feels like they're dehumanized when they are using a system, right? So whether their dignity is not, and then their worth is not valued in how it should be. And the idea is that how much do you trust that? Does the user's perception of how they're affected actually a good marker for a system designer to take, or not, right? And there's not a lot of good, those can be very important signals, but there's not a lot of discussion of how much we should take that into account in risk assessment. And so we were hoping, our goals are by applying the system safety perspective, we're hoping that mapping these measures and understanding which parts of the system they're assessing, we can, from a governance and a policy perspective, we can see the blind spots of what parts of the system is being assessed and what parts are not being assessed. And that could be a useful tool potentially for people that are involved in the governance and policy work to sort of use. We also thought that from the industry and practice perspective, and there's been an allusion to this in the sense that this can help us be more transparent about what types of measurements are being used and not being used, and we can be more clear about what parts of the system are being assessed and what parts of the system are not being assessed. And then ultimately, I think when it comes to research, there's a lot of works that are being proposed on measurements, but and some loose links that are being made between these measurements and potential hazards and harms. But these links are quite loose and a bit of a stretch. And so it would be really nice for researchers to try to have better, sort of more justified links between the measurements that they're proposing and sort of the hazards and harms that they are claiming to assess. And so lastly, hopefully this one will play. Okay. Yeah, so we've created a visualization of this data set. You can see that, for example, fairness is a huge category of measures, with many of the measures mapped to model and output. And then you can see that most of the fairness measures were looking at representational quality of service and allocated harm, which is not that surprising. And so this is a visualization just to sort of see what is the lay of the land and what we had captured in their set. So really, at the end of the day, this message is like echoing what some of the conversation has been going on earlier today, which is some of the model metrics that we're developing, whether they're benchmarks or whether they're different specific measures related to principles. They don't necessarily indicate, they don't equal to user level harm, and that we should be really clear about some of the normative choices that are being made and try to sort of make this connection between these measures and harms and ultimately risk. And that we think, and the proposal of this work is that taking this system lens and seeing where these measures fall can help us get to that point. So yeah, thanks so much for, I know it's the afternoon, probably everybody wants to grab some coffee, but thanks so much for listening, and I'm happy to take any questions. Yeah. Yes. Yes. Yeah.
There's no micro.
Yeah, no, thank you for that. I think that it's really interesting because I think for a lot of this work, I would say is targeted primarily at safety practitioners or individuals that are along that pipeline. I've done this project where I tried to, and I think there's a lot of conversation in sort of going on in the field of oversight and reliance as well when it comes to how much should we trust users in sort of monitoring these systems or exercising oversight, and how much information can they actually take, and effectively use ultimately. And there is research, that shows that basically the more you explain to the user doesn't necessarily mean that they actually are going to use the system in a safer way. It might actually mean that they end up trusting the system more and still use it in a way that is incorrect. And so I think that is, I think for me, like when I look at that, I think there is a huge problem with this whole idea of, or assumption. And I think policy to an extent is like saying, oh yeah, users can have oversight over the system. And I think that's not necessarily, I think there's decades of research and sort of HCI has shown sort of like potential pitfalls of that. And I don't necessarily think that, maybe to select set of users, showing these, showing sort of the nutrition label or showing the sort of the opening up the box and sort of showing that might be valuable for them. But that will be probably mostly very highly trained sort of users that would be able to actually do something with this information. I think primarily this type of work has to be done from like I think right now these judgment calls are being made in industry about sort of what to measure, how to measure, and what that really means. And I think this type of work, I think primarily helps sort of make those judgment calls a bit more clear and sort of create this traceability. And I think that's where this would be more valuable. And that, yeah, ultimately, I think we really need to, and this is something I'm really interested in doing, is this really question this like whether oversight is something realistic for users to have for us to have an expectation of. Yeah. Thanks for the question. Yeah.
Hi there. I had a question. I'm wearing my ML Commons hat. One of the concerns I have with the paper is that it seems very biased Western-centric values. For example, the literature I assume was primarily in English. One of the concerns, we have a lot of customers and members in Asia where the values that you listed there, they don't have. They have a very different system. In other parts of the world, and I don't have to name them, different parts of the world, not, let's say, Western Europe and North America. How does this work scale to that? Because we have to be global in nature. My concern is that, in countries where they don't have these value systems, and we try to come, and I've experienced this personally, when I go to the International Standards Organization and we say, hey, we would like to standardize a benchmark for assessing the fairness or safety or security of everything, an entire political storm starts. And to me, I'd like to understand how your work can be extended, because I feel it's culturally biased to the West.
Yeah.
Thank you.
Yeah, no, thank you. Yeah, thank you for asking that question. I mean, I think this work, to an extent, yeah. So I agree. I think that the body of literature that we're capturing is, computing literature, which I think in of itself has bias in terms of where it's originated from. And I think also the work itself shows bias towards specific types of principles that are valued more. So in that sense, it's, we're already seeing that this bias exists within the computing community, which I think one of the things that we wanted to highlight in this work is that, are these the principles that we should be primarily focused on? Because it seems like we're really going down this direction of really focusing on these sort of principles. And then maybe we should be taking a step back and like trying to look at some of these other principles that might be important for other different regions. So in that sense, I think this work doesn't necessarily, we haven't proposed, we're just showing that gap of that certain principles are prioritized more already within the computer literature, and that maybe that is biasing us as a whole to go towards these principles. And so in that, but I think beyond this, I think what this sort of work shows, or what we're trying to sort of to go for, is that there are when we make these, we're asking people to basically make this connection between what components they're measuring, what's the attribute of that measure, what is the hazard that the attribute sort of signals, and what's the harm. And if this line of thinking is completed, like if this line of thinking in these judgment calls are clarified, then I think it'll be clear to sort of see that, okay, these are the harms that we ultimately care about addressing, and these are the ones that we're going to prioritize at the level that we're at within the community that we are. So I think in this sense, I think that can be one direction. And ultimately, I would say like one of the ways we are thinking about potentially moving on with this project is to see if we can make it into a form that individuals, in a more of an open source format, where we can have individuals contribute different measures that they are developing into this sort of body of work. And so this can go beyond and sort of something that is more of community oriented. And so that is sort of within works right now, and to see how we can make that happen. But yeah. Yeah. Okay. Any other questions? Ready for? Okay. Well, yeah. Okay, well, thank you so much, everybody. Yeah, thank you. And yeah, I think hopefully we'll chat more later. Thank you.